Alright, so this is the next in our series of videos on derivatives for Math 1560, Calculus 1 at U of L for fall 2017. And in this video we're going to introduce one of the the one derivative rule that probably everyone knows, which is the power rule. Um, so here's what the power rule looks like. We're going to start out stating this for a positive integer, and then we'll see that in fact you can extend this rule. But proving this for exponents other than positive integers is going to take additional techniques. Essentially, we're going to need the chain rule, we're going to need logarithms if we want to really nail things down. But the basic power rule, we can work it out like this. Well, how do we deal with any sort of derivative if we don't know anything else? We go back to the definition. What does the definition say? The definition says that f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h. And so here that looks like this. It looks like the limit h going to 0 of x plus h to the n minus, ignore that box there, minus x to the n over h. Okay, so as you would expect, it's a 0 over 0 limit, and we need to do some simplifying so that we can cancel those zeros and get our answer. So how do we simplify here? Well, what we're going to have to do is we're going to have to expand this binomial, and the way we do that is using the binomial theorem, which you may have encountered in high school. I've been told it is on the curriculum, even if nobody ever seems to know it. So the binomial theorem is this statement here. It tells you how to expand powers of binomials. So if I have a sum of two numbers, a and b, and I want to raise it to the nth power, the binomial theorem says that you can expand that sum as follows. A to the n, and then n, a to the n minus 1 times b. The next term, so these numbers, these are the called binomial coefficients. They're read as n choose 2 because they're also related to permutations and combinations. It tells me the number of ways I can choose two items out of a set of n items. A to the n minus 2 times b squared, and so on down to n a b to the n minus 1, and then the last term is b to the n. Okay, so that's the binomial theorem. So a general term in this expansion looks like, so one of the terms in here would look something like this: n choose k, a to the n minus k, b to the k, and k could be 0, 1, 2, all the way up to n. So we don't need to worry too much about this. In particular, we don't even really need to know how to calculate all of these numbers because we're going to see that most of them don't come into the picture. If you're wondering where those come from, these are the numbers in Pascal's triangle. You might remember that there's this triangle you can generate that gives you the coefficients when you expand these powers. Okay. So, 1 and so on. Anyway, if we expand our binomial with x equals a and h equal to b, we expand this binomial here, then we see that what we get is going to be the limit. Okay, h going to 0, so the first term is x to the n. The next term is n times x to the n minus 1 times h, plus some other stuff. And the key thing to realize about all of the other terms is that all the other terms have at least two h's in them, right? The next term is going to involve h squared, then h cubed, all the way up to h to the n. And we don't need to worry about those because we can see that things start canceling, x to the n minus x to the n, and those cancel out. And what we are left with, h goes to 0. If we factor out an h, we have n, x to the n minus 1 plus, you know, a bunch of other stuff that has at least one h in it. And so when we divide by h, these guys cancel out. H goes to 0, and so when h goes to 0, all of this stuff disappears, and we're left with our result, n times x to the n minus 1. So that's where this formula comes from, just in case you've never seen the derivation before. And so what the power rule says when you're using this in practice, right, is just notice that what it's telling us is that when you want to take the derivative of a power, the power comes down in front, and then you subtract 1 from the original power. Okay. Now, we'll talk about other powers in a second, but let's just do a quick example. So if I wanted to take f of x to be, let's say, x to the 7, then f prime of x would be, so the 7 comes down in front, I subtract 1 from 7, my new exponent is 6. So I get x to the 6th. If you like using the Leibniz notation, you could write this as, well, the derivative with respect to x of x to the 7 is 7x to the 6. Okay, just as an aside. So you can also use the power rule for other powers. So the power rule still applies for, in fact, any real number a. Okay, so if you want to take the derivative with respect to x of x to the a, it doesn't matter what kind of number a is, right? It could be a fraction, it could be negative, it could be a, you know, an irrational number like a root. It doesn't matter. The power comes down in front, and you subtract 1 from the exponent. Okay. So, for example, if we wanted to do the derivative of, let's say, x to the minus 5, power rule says the minus 5 comes down in front, and if I subtract 1 from minus 5, so be careful here that we're doing minus 5 minus 1, right? It's always minus 1. So subtracting 1 from minus 5 takes me to minus 6. Okay, or if I was doing the derivative of, let's say, x to the 1/3 cube root function, the 1/3 comes down in front, 1/3 minus 1. Subtracting 1 from 1/3 gives me 1/3 x to the minus 2/3. Okay. So that's the power rule. In the next video, we'll look at the sum and constant rules, which are going to let us take this power rule and extend to objects like polynomial functions.